Glad to be here. I wanted to give this talk because I know that there's a lot of kind of low-level stuff going on way down in the guts of Cassandra. That's all really important. We want the committers and the guys who are writing the code to be able to get down and have those conversations. I'm not a committer. I'm a developer. I write applications on top of Cassandra. That's my main concern. It's always been my main concern. Yes, I work for DataStax now as a developer advocate, but before I came to DataStax, I built a large reservation system using Cassandra as the primary data store and skinned my knee a few times, as you can see here. So a lot of this talk comes out of real world experience and not just being a DataStax fanboy. So just wanted to let you know where I'm coming from and what my perspective is, and also set the expectation level. This is a breadth first talk. So I'm gonna hit a number of high points, point you to some resources and to some things that you can go and have a look at for more information. And most especially, I want you to come and talk to me afterwards. I'm gonna be hanging out at the DataStax table in the lobby during lunchtime. We brought 25 copies of Cassandra, the Definitive Guide. I did the second edition of that, so I'll sign a few copies of that. So come on over and say hello. And ask me your hard questions. And if it's really hard, I'll find Jonathan Ellis and then it'll be good. Okay, so here's the top 5. I'm not going to bury the lead here. So here's the top 5 points about getting the most out of Cassandra. Right here, this is what we're going to go through for the rest of this talk. Okay, so first of all, don't try to use Cassandra for everything. Know when to use it, not when to use it. Second, get your data model right. Super important. Can't say that enough. Third, get smart on application development. I'm going to share some anecdotes from my personal experience and the experience of others of people who have made bad implementation choices which make life harder for everyone else, especially those who are responsible for maintaining those databases. So I'm going to talk about getting good at ops or outsource it. And the final thing is really to give something back. So there's ways that you can contribute to the community. Even as a developer, not as a person who's a committer or fixing JIRAs. Okay, there are ways that you can participate and give back. And then my little coda here with any time I have remaining is really just to share kind of a catalog of resources that we make available to help you improve yourself, get better at developing with Cassandra. So this is where we are headed. I've put my, my Twitter handle at the bottom of the slides. That's always on there, so you can remember that and interact with me. And when you take a picture of the slide, if you choose to do that and share it, then you will remember to reach out to me. So, okay, when I was at Choice, I did a talk, and actually it was 2 years ago this week at Strata, New York City. I did this talk about how we designed a system, our reservation system for Choice Hotels, where I was working, brand new reservation system in the cloud running in AWS, mostly on top of Cassandra. And then the Spark was, I guess, a little bit more of an aspirational thing at the time. So we were kind of building up into that. And what I presented was how we did a microservice design of using domain-driven design principles from the famous Eric Evans book to derive the different domains that were part of this hotel reservation system, and then derive the data models for each one of those, and then put a Cassandra database underneath every single one of those. That was wrong. That was a mistake, and I shouldn't have done that. And I had a really good reason for doing it at the time, which was operational simplicity. If we're building a new reservation system, I've got what originally started out as 2 dev teams, which quickly grew to about 10 or more dev teams, 4 of which were working on like the very core guts of the reservation, the kind of the booking and scheduling algorithms. And then there was a bunch of other teams that were doing integrations around the edges of that. Those 4 core teams, I had every single one of them dropping all their data into Cassandra tables. As I've kind of matured and grown as an architect over time and realized some of the mistakes that were made there, yes, it was true that there was some operational simplicity that came from only running one kind of database in production. And yes, we did reuse clusters and share the workload so that all those different data types were actually on a single cluster. So it wasn't like we were wasting vast amounts of resources. However, it meant that all those teams had to learn Cassandra and come up to speed. Some of them were really enthusiastic, like the first 2 teams. And then the next 2 teams after that were like, what is this that I have to learn? Why can't I just use Oracle, right? So there were some organizational challenges that came there. But architecturally, what I realized was it wasn't the right database. Cassandra wasn't the right database for all those data types. So where did we really need it, and what drove us to using Cassandra or thinking about it in the first place as we went to the cloud? It was the large volume where we had lots of writes and a really high volume of data. So this is thousands of hotels multiplied by many, many days of inventory, let's say 2 or even 3 years out into the future, and all the rates for all those different types of rooms, et cetera, that many 5,000 or 6,000 hotels worldwide at the time was what Choice was targeting. That's a lot of rate and inventory data. And there was also a lot of reservation data, high volume of reservations. So we really needed the scale that Cassandra provided for that. What we didn't need it for was the hotel catalog. The descriptive catalog information for 5,000 hotels, there was no need to put that in Cassandra. And in fact, that would have been a really awesome fit for a document database. And that's what I should have done. But I didn't. We put it all in Cassandra. So same thing with customer history. That's a great example of a graph use case that we could have built toward, and that would have been a perfect application for a graph database like DSC Graph or one of the other products that's available. And then we had some really extremely low volume, like reference lookup data tables, like country codes. There was an actual, we wrote a service. This is a definite classic example of a microservice, emphasis on micro, right? A country service that all it did was look up country codes and translate one to another. There's no way that that needed to be on Cassandra. Okay, so more balanced approach is let's use Cassandra for the things that it's really good at and not waste our time on other stuff. Okay, so I want to use Cassandra when I know that I'm going to have large scale, when I have high availability requirements, and most especially when I know that I want to operate across multiple data centers or even across multiple cloud providers. I'm going to do another talk that's a little bit later on in this same room this afternoon where I'll talk about some experiences that we're working on right now at DataStax on the developer advocate team to take a reference application that we have and run it in a multi-cloud environment. So we definitely have some lessons learned and some things to think about there. So I'll get more into that side of things a little bit later on. A couple other things that are good indicators of when to use Cassandra or not to use Cassandra. If you have a situation where you're going to be doing totally ad hoc queries, like you really have no idea, you might want to query your data along any axis, that's going to be a little bit harder to do with Cassandra because you want to lay out your tables beforehand. This is the data modeling topic that we'll get into in a second. You want to lay out the tables to support the queries that you're going to have. You can support a little bit of some kind of ad hoc search kind of capability, and I'll talk about how to do that later on. But it's not based on just the core Cassandra by itself. And then if you really do have very strong consistency guarantees and ACID transactions that you really need consistency across multiple tables and really have to lock that down, then Cassandra probably isn't going to work and be able to handle that and could be a source of frustration. However, I've been in a lot of situations where people made claims of needing to have that super strong consistency, and as we kind of walked through the different cases, it really became clear that that wasn't as strict of a requirement as maybe people thought. And I'll give you an example from the hotel world. We had this reservation system that we were building, and there were claims being made that we had to have super strong consistency where the inventory counts had to be in lockstep with the reservations. In other words, I needed an ACID transaction across the inventory table and the reservation table. That was the assertion. Come to find out that in the hotel world, you have a central reservation system, and then you have a system on property at each hotel. The source of truth of what reservations and inventory are at each hotel is that hotel's on-premise property management system, not the central reservation system. Therefore, if I had 6,000 hotels, I had 6,000 sources of truth and one central reservation system that was subservient to what was on each property. So I could definitely try to enforce very strong, strict consistency guarantees on a central reservation system, but I have 6,000 external sources of entropy that I'm integrating with. And so I called into question at that point, how important is it really the upfront consistency when I can, and in fact, I'm continually doing consistency checks with these external property management systems. So that's just an example of push back on these strong consistency guarantees, especially when you're at scale and think you might need Cassandra. Okay, so the second point, this is 2 out of 5, getting your data model right. Now, if you have spent any time trying to come up to speed on Cassandra, you've probably heard this, but we all need to hear it again. And even when we think we're experienced Cassandra users, we have to do this again and again to get our data model right. Okay, so one of the things, we are making a deal here. When we're using Cassandra, we're saying, I recognize that I have all those attributes that I mentioned on the previous slide that are driving me toward it. I need high scale, I need high availability, I need the ability to absorb a lot of writes, and so on. To do that, you're going to have to play by the rules, which is designing according to good data modeling principles, and you're going to be designing in such a way that you design the table that supports the query that you know you're going to have. So you're making a single query that's hitting a single partition and bringing back all the data that you need in that one query. That's your goal with Cassandra data modeling. That means that if I need to store the data in multiple representations to support different queries indexed by different attributes, in other words, doing my own denormalization, then I'll do that. Manual denormalization or managing your own denormalized tables is still probably the way to go in most cases. There is a materialized view capability that was introduced in Cassandra 3.0. You should read the fine print and educate yourself on the different cases. I don't have time to go all the ins and outs of it here. There are cases where it works, and in fact, DataStax has our graph product, DSE Graph, actually makes use of materialized views. So they can't be that evil if there's no case where they would ever work. And actually, there are cases where they work just fine. But you definitely have to be careful about how you use them. So that being said, there are cases where you have this tension between multiple data types. So the example that I showed previously where I had a service that was managing hotel data, and I had a service managing inventory data, and a service managing rate data. Those were different cases where I had separate services that were owning data types, but in order to satisfy the functionality of the system, I needed to have some capabilities that were looking across both of those. So for example, I'm shopping for a hotel room. I might need to pull some information about describing a hotel, and then what inventory it has, and then at what prices or rates I can buy that. If I were going to go totally the Cassandra way of modeling things, I would actually probably have a table that stored the data such that it was indexed by date, and I would do a query, and I might use a static column to store all the hotel descriptive information, and then I would have the rate and inventory information all categorized in a single partition. So I do one query and I get all that information at once. However, that kind of violates my microservice boundaries that I've drawn. So those things are kind of held in tension there. And I don't have necessarily the one magic answer for that, but those are trade-offs that you need to consider. Is I have a service and it quote unquote owns a certain set of data. If I want to have a good microservice application architecture, if that's the case, then it owns all the data that's underneath it, and one service might have it in Cassandra, one service might have other data, and then I might be in a situation where I need to do joins at the application level, and that's okay. You have trade-offs. Some application level joins are manageable, and then you may get to a certain level of scale where you just can't handle it anymore, and then you have to start thinking about combining some of those data types together across services. What I would say is I would let the scale drive you to that architectural decision where you have to start aggregating things. Just another note I want to share here too. If you really are in a case where you need to do ad hoc searches across multiple different columns in your table, you can definitely denormalize and begin to design more and more tables. However, as you have more and more tables that you are writing data into to maintain denormalized views, there gets to be a point where you're doing a lot of writes, and that's really going to start slowing things down. Now, personally, once I got up above 3 or 4 of those denormalized tables, that was when I started to get uncomfortable, because I had developers organizing writes into multiple tables using batches, which we will talk about in a little bit. On the other hand, I was talking with Patrick McFadden yesterday, and he was like, yeah, I've seen denormalized table design approaches where people were writing into 20 different tables. So that's really kind of a trade-off that you're going to have to figure out how to manage yourself. And then you'll have to excuse my little plug. I do the occasional product plug for DataStax Enterprise where I think it makes sense. And I'll tell you actually why, the reason that I mentioned this to you. I definitely had cases that I ran into in that reservation system that we were building at Choice where I really needed to be able to do some searches that I could not, there was no way to support in just core Cassandra itself. And the number one was the geospatial queries. I needed to be able to get at where the hotels were, that location information, and I had no geospatial search capability that was available to me to really find the closest, if I given a lat long location, find me hotels within 10 miles. I had no way of doing that. So we actually built a solution that cached all that information in memory. I much rather would have been able to just rely on the database for that. That's a perfect use case for DSE search, and that would have been a great solution for Choice rather than trying to go and build a whole separate search cluster capability. So there are cases where there's really a definite value add of having an integrated search capability. A couple of anti-patterns to avoid with a data model. Definitely allow filtering is not, if you've ever run a query where you're trying to do a scan across multiple partitions, you'll get that allow filtering warning. The thing is, you probably want to heed that warning. In other words, don't do that scan. There are cases where if you know what you're doing and you know that it's going to be isolated to a certain level, or you know that you can set paging and you're willing to make multiple page requests to get your data a little bit at a time, you can certainly live with that. What I found in the case where I had a developer that ignored my advice and unbeknownst to me at the time, coded in that allow filtering and overrode that capability, the system performed well as we were adding more and more hotels onto the system. And then there came a time where things began to get slower and slower. And this actually turned out to be in the rates portion of the application. The rate queries ended up getting slower and slower and slower. And then we were, pretty soon after a while, we were in timeouts. So we were increasing timeout values. And I had to hit the pause button at one point and say, probably increasing the timeouts is not the right answer here. This is starting to slow down. And come to find out, as we went back and investigated things, there was a sort of a clever implementation that had been taken, probably too clever, that was basically, once we got up around the point of where we had like half the hotels, about like 3,000 hotels worth of rates in the system, things were just ground to pretty much a complete halt. And we really needed to go back and look at the table design and kind of hit the reset button on that. And that was a lot of rework that could have been avoided if we would have not kind of ignored the warnings up front about the allow filtering. So real world horror story there for you. And then there's a few other anti-patterns. I would encourage you, we have some different references on data modeling that you can go and learn about best practices and how to data model. There's a few anti-patterns. One of them is anything that uses Cassandra as a queue is not going to be a good use case. And there's a few others that are kind of like that. So I'll refer you to a few of these resources. DS220, the most popular course on DataStax Academy. Data modeling. Everybody wants it. Everybody needs it. That is the money course that will help you more than anything else. And then there's some other things that are available. If you want to see a good example of a data model in practice, you can look at our KillrVideo reference application that's available on GitHub. So KillrVideo, there's no E in killer, so it's K-I-L-L-R video, as you see here. And then I have a blog series where I attempt to kind of go the next level beyond, maybe it's the 300 level data modeling class. Although it's not just about data modeling, it's also about some of those application architecture questions that I was discussing before. So these are some resources, and I guess the one other thing I'll mention that's just a bullet there at the bottom of the slide is the O'Reilly book, the Cassandra Definitive Guide. Chapter 5 of that book is actually available for free on O'Reilly's website. So you don't have to buy my book. You could just go download Chapter 5 for free. And that walks you start to finish through derivation of a data model. Okay, application development. This is our next topic here. So this is topic 3 out of 5. We want to get good at application development with Cassandra. You can have a really good data model and then kind of screw up your life by making some bad choices. So I'm going to hit a few highlights here. We are actually, one of the things that we looked at DataStax Academy is we don't have as many resources as we'd like to have on application development. We're working on a course right now, a brand new course on application development. So some of this material you will likely see in one form or another in a new course that we're working on. Okay, in most cases you'll be using one of the DataStax drivers that we provide. We have versions of the drivers that work with open source Cassandra, and then if you're a DataStax Enterprise customer, there are also DSE versions of the drivers that add in the search, analytics, and graph capabilities. So if you're familiar with the API, you create a cluster object to get a connection to multiple nodes in a cluster, then you create a session that is optionally bound to a key space. You usually bind that to a particular key space, and then you can get access to the different tables. You want to, the session object itself is pretty resource intensive. So it's creating thread pools and maintaining connections, etc. It's a fairly heavyweight object. You would like to have one of those if at all possible. So I've seen cases, and in fact the worst case scenario that I saw was a case where somebody was implementing a RESTful API, they received a service request, instantiate a cluster object, service the request, throw it away. Yeah, that didn't scale very well. That was a pretty low throughput service. So create one session, keep it around for the lifespan of your service or application, and you'll be in much better shape. If you are using one of the language variants, not every version of our driver in every language has a mapper, but several of them do. If you are using one of the mappers, the same principle applies. So think, if I have an instance of a mapping manager, that's got a session embedded in it. So same issue. Don't create multiple mapping managers. So asynchronous operations. We had some fun debates about this on our developer advocate team in this KillrVideo reference application that we maintain. We actually have converted that to almost exclusively use asynchronous operations, and that's for reasons of application responsiveness, thread management, and scalability. So what I mean is, where there is an asynchronous variant of a command on the driver, we typically use that instead of the synchronous variant. It does make, in my opinion, okay, as maybe an old school guy, sometimes it can tend to make the code a little bit less readable, the fact that I'm actually implementing a callback that's getting my results from the driver. But you're definitely going to reap some serious rewards in terms of just kind of the scalability and the responsiveness of your application when it kind of gets that load on top of it. All right. We support multiple ways of executing statements in the drivers. You can just create a basic or simple statement and where you're actually constructing the string yourself. I like to use prepared statements whenever possible, and that's actually for two reasons. One is the performance benefits, where we create a prepared statement, and that's basically the structure of the statement is sent off to our nodes, and then all we're really sending is the values that we're plugging in. So that means every time we do a query, we're sending less information So that's gonna obviously improve our performance. The other reason is that it's a security measure. You know, I've never heard of a CQL injection attack in the wild, but such a thing is certainly possible. And the prepared statements is really a way to kind of mitigate against that. Okay, so I mentioned batches a little while ago. That's a way of combining multiple insert or update statements together. It is going to be a little bit less efficient. If you think about how Cassandra does writes, you have a particular table that you're writing into. You're going to hash based on the partition key, and that's going to go to specific nodes that are meant to hold that range. And if you're doing a batch, then you're actually farming that out, and you're saying, I want all these things in the batch to complete together, and you're actually writing to multiple partitions and different tables, which could be begins to be a wider set of nodes, and you're actually touching more and more of the nodes in your cluster to do that. So there is kind of an upper limit from a performance perspective of how many writes you want to put in a batch. I don't have a hard number for you, just know that it's going to get worse the more you put into a batch. A lot of people, when they hear that concept of batch doesn't mean like a bulk data loader. It really just means a way of coordinating multiple writes that you want to succeed or fail as a unit. Some other things, there's a simple example here that basically be sparse on your writes. So if there isn't a value that you need to write, don't write null as this bottom one does, because that actually creates a tombstone. So I didn't do that one myself, but I do know people who have. Time to live, you should definitely take advantage of this. We actually did this a lot in the reservation system, where we wrote rate and inventory data with a TTL such that it would expire basically like a day. We put like a grace period of a day on it, so that a day after the rate for a particular date, it would just kind of expire out of the system. This is a preferred way of handling deletes in the system, is actually to let Cassandra handle it through compaction. There's a couple different compaction strategies that you can research and look at. The time window compaction strategy, and there's a date tiered compaction strategy. And I'll let you research that one about the best times to use that in the interest of time. All right, I'm going to skip over the data center awareness just in the interest of time for now. I'll just say that I tend to prefer operations on the local data center just in the interest of latency. If you're doing reads and writes and you're waiting for responses from other data centers, that's going to slow you down. Basically, the reason you want to let Cassandra kind of do its work in the background. So next, if you really have a case where you feel like you need strong consistency, use Quorum on read or write. If we have a consistency level of 3 nodes, that means for Quorum, that Quorum out of 3 is 2. So that means I'm going to write to 2 nodes, and then I'm going to read to 2 nodes, and that way if a write completes, I'll be guaranteed that I get that value on a read. I had a case where you want to be careful before you start to relax consistency levels. I had a case where we were writing through maybe a questionable application design. We were writing a rate information to a table and then immediately reading it back out. So what happened was we were kind of bulk loading some data and writing into a rate table, and in the interest of speed, we wanted to speed things up, so we went we changed a Quorum write to a write at consistency level 1. And then every once in a while, as we did this read immediately after write, every once in a while we would get the result that the data wasn't there. It was because we were writing at 1 and reading at Quorum, and every once in a while, statistically speaking, it happens more often than maybe you would intuit, but if you do the math, you'll figure it out. And we were getting data that wasn't there because we relaxed a consistency level. So you just want to think about these things before you begin to relax consistency. I already kind of made this point, but the goal is consider whether you might be okay with just using a local quorum instead of a quorum for your use case. And it's a consistency question. How immediate of a consistency do you actually need across data centers? Okay, this is my one place where I'm going to get opinionated, and I don't like to call things out very often, but people ask sometimes about Spring Data Cassandra, and I'm honest with them and say that I wouldn't use it. And in fact, at one point, I actually a team ignored me. I was in an architectural role, so I had authority to do this. A team went ahead and implemented it against my wishes, and I made them go back and rip it out. And here's why. So there are some practices that that this encourages. Basically, it's trying to provide like a one-size-fits-all database API on top of things and abstract out the details. The problem is that Cassandra is not a traditional relational SQL database. So there are things in the Spring Data API that really aren't a good fit for the way that Cassandra is architected. And the number one is this example of kind of like the get all command, which is a full table scan. You really shouldn't be doing that in Cassandra, but then it's right there in the API. So, and that's not the only example. There's a few others. We can kind of go into the details if you want. What I would say is you picked Cassandra for a reason. You picked it because you needed the scale, and you made the bargain that you were willing to kind of take on those database modeling trade-offs that I spoke of earlier. This is a way of trying to get the scalability benefits of Cassandra without actually doing the hard thinking of creating your data model right. That's the argument that I would make. So you're trying to shortcut something that is probably not something that you should shortcut. Okay, I'm not an ops guy. I'm not an operator. I will confess that up front. But one of the challenges that I encountered in the company that I worked at was finding people that were good at ops. If you're Twitter or Netflix or Uber, you definitely, you have that competency and you can afford to pay people and pay for the best. Some other companies, it may be harder in some cases to find people and to grow that competency. So some of the challenges that we ran into was sort of the classic, it worked on my test data set, and some of the bad implementation choices or bad configuration choices that we made with best intentions and fully studying the different configuration options and selecting the right compaction strategy and all these sorts of things, you don't really know until you get to scale how some of those things are going to perform. So some practices that I would recommend is do testing at as large a scale as you can possibly get to. If you can use Cassandra stress to stress test your data model, that's great. That's going to really help you a lot. From a configuration and tuning perspective, we went through exercises where we would kind of scramble and like, this doesn't seem to be working, so I'm going to change these 5 things in my config file. That's not really the scientific method, okay? So if you're changing multiple configuration values at a time, that's probably, you may not actually know what you're learning at that point. So there are definitely, in most cases, you can change things on one node at a time if you're trying to test out different configuration and tuning settings. Or in some cases, you can also create like a shadow data center and just do some testing on that where data is getting replicated to another data center, and then you can kind of hammer on that and see where things go. There are definitely ways of isolating what's happening so that you can use more of a data-driven scientific method to test out your config changes. Or you can outsource your ops. So DataStax is offering managed services. We have an offering that we have right now called Managed Cloud, where we'll manage a cluster for you and help with some other things like help you design your data model and tuning things for you. We have more offerings that are not public yet that we're working on in this cloud area. So kind of watch this space for more information about what's coming from DataStax Cloud. My final thing that I want to do before I wrap up is mention some ways that you can give back to the community even if you're not down in the guts of the database changing code. So I've many examples of friends and acquaintances who just answer, they're on the mailing list, they're not on there every day, they're not the well-known person that's answering all the questions, but every once in a while something comes up that's kind of in their sweet spot or area of expertise, they pop on. And this is not, I'm not talking about DataStax employees, I'm just talking community members at large that'll go on there and answer a question. So 4.0 release is coming out. We need some documentation review, we need some testing. Get on and help with these things. Or there's a new blog that's been developed for the Cassandra community. You can get on and learn about that and write a blog post about how you're using it in your case. And then I'm going to hit a nerve close to home here. Do you ever see stuff like this where the Apache Cassandra homepage and you go to the product documentation and it says under overview it says to do, and then every month or two somebody does a tweet like this. Have you seen this? I'm sorry if you're here. I'm really sorry. I'm not trying to call you out. Maybe I should have fuzzed that. I will think about that. This person is calling, I'm not trying to criticize this. This person is calling out something that we need to be called out on, which is that we need to improve our documentation as a community. So I'll encourage myself and all of you that we can definitely even not just people, developers and users, people that love Cassandra, we can contribute to this and make this better. You can also help me. I am looking into the possibility of doing a 3rd edition of the definitive guide for Cassandra, kind of coinciding with the 4.0 release. So it's Jeffrey S. Carpenter on GitHub. And my Cassandra guide repo, I basically just have like this page, this README, this markdown file where I'm collecting chapter by chapter improvements. If you don't know the structure of the book and don't know what chapter to recommend I make a change in, that's fine too. I'll take any recommendations about how to improve the book or new topics that I should include. But if you want to help contribute to that and help me talk O'Reilly into greenlighting a 3rd edition of the book, that would be great. So that's just another way that you could help out. Okay, I have no idea how I'm doing on time and where we're left. 7 minutes. That's perfect. Okay, so I'm going to hit a laundry list of things that you can use to help improve yourself and get smarter with Cassandra or DataStax or both of those things. So DataStax Academy, we definitely have course material that is based on the Cassandra open source, and then you can also, of course, learn and get smart on all the DataStax additions to that. I won't give you the whole catalog of courses at Academy, but we definitely have a lot of things available. We're also doing some tweaks here and there with our Academy content. If it's too heavyweight for you to try to think about getting your head around taking a whole course, we're trying to move things to where it's more kind of topical based, so that if you just need to drop into the middle of the course and just like you're really struggling with compaction and you just want to take a unit on compaction, we're trying to make that easier and more accessible to get to. So we have initiatives like this, learning paths, and then we have another little project that we're working on to kind of make this just better and more accessible to you for both open source and DSE topics. Weekly podcast, you knew I would have to give that a plug. Distributed Data Show comes out every Tuesday. So we have our whole advocate team that participates in the production of this show. Actually, we would love to have more folks from the community on. So actually, if you have an interesting use case or are interested in coming on the show and talking, please hit me up afterwards. You might get me as the host of your episode, or you might get lucky and have Amanda. That's our newest developer advocate. You might get Amanda as your host. Either way, hopefully you'd have a good time and enjoy that. Our most kind of edgy new thing that we're doing is live coding on Twitch. We're trying to do this every Thursday afternoon. Jump on and do some hacking. Some of it's on the KillrVideo reference app, and some of it's just kind of like random other stuff. If you have some interest in topics that you'd like to see us hack on, we're also looking for topics for those. If you see Adrian around today, Adrian Hall is another one of our new developer advocates, and he's on Twitch all the time doing stuff. So check out KillrVideo, and I will wrap up for now. So thanks everyone, appreciate it.